Okay, number one, I have 3x times x plus 2, x plus 3 squared. Now, again, some people accidentally, okay, not thinking, made x plus 3, whoa, what happened? There we go. Made x, oh boy, something's happening with my board. Let's try it again. Okay, so I have 3x, x plus 3 squared. Okay, some people were making this x squared plus 9. Okay, and obviously that's not right. Now, you can also go ahead and take the 3x if you want, okay, but that would also not be correct because you have to do your exponents first. So I have 3x times, now we're going to FOIL this out to where it's x plus 3 times x plus 3. So when I FOIL that part out, I get x squared, okay, and then I get 3x there, so that's going to be 6x, and then I get 3 times 3, which is 9. For some reason in the middle of my board there's a blank space. Okay, so now once I have this, now I can distribute the 3. So I get 3x to the third plus 18 x squared plus 27x. Okay, and that of course is letter D. Okay, any questions on 1? Okay, number 2. We did this one while you were taking the test, okay, or while you were taking just kind of the pre-assessment. All right, so I have 2, 5, 10, and 17. Now, if you take a look at what that's telling me that that is T. N is the number, okay, the term it should, or I should say the term number 1, 2, 3, and 4. Okay, now we can plug and chug, okay, which is probably the easiest way to find out. Just keep plugging in into all 4 options, okay, or what we could do is when we look at A, B, C, and D, or D, okay, I have n plus 3, and I have n squared plus 1, man alive, okay, C, 2n, all right, plus 1, and then 3n minus 1. All right, so plugging in the values of n to each of these, what's the only one that works?
B.
B, okay, because when I take 1 here, 1 squared plus 1 is 2, okay? A and C do not work even with the first term. Now if I come down here to D, it works with the first term, the second term, and the third term. I'm sorry, just the first 2 terms. It doesn't work with the third. So when you're taking the EOC, okay, make sure you're looking at every single option, okay, because they may actually flip D and B at one point, okay, and you are thinking, ooh, I found it, okay, and it's not correct. All right, now, number 3, okay, systems of equations. I have x plus 4y equals 100, and both of those are over 3. Then I have 3x minus 4y equals 100 as well. Now, what our goal when we see a system of equations is to get rid of either the x or get rid of the y. In this case, if I make this a 4y, and since this is negative 4y, this is the one I'm going to choose to get rid of. Now, how do I make these 3's go away? I'm dividing by 3, so how would I get rid of it? I would multiply by 3. So I'm going to multiply everything by 3. So now I have x. Yeah! Sorry. X, okay. Those cancel. So now I have plus 4y. All right. Equals 300. Okay? Okay. Do y'all know that's an X? Please say yes.
No, I don't know. You have right.
Ha ha ha. Okay, this is an X, even though it looks like a DERF. Okay, this is an X. So 3x plus x is 4x. The y's cancel. And so now I'm left with 400. So now what do I know that x equals?
10.
X equals
100.
100. Okay, so now that I found x, how can I find y?
Plug it in.
Yep. I'm going to plug 100 right here where, haha, there's an x. Okay? Or I could do it at any of these. It doesn't matter. But anyway, we're going to come to where we plug 100 here in, subtract from both sides. So now I have 4y is equal to 200 and y is 50. Okay. What are we looking like on time?
6:45.
6:45. Great. All right. Now, number 4 does not require any math. Okay? How I would solve number 4 is that I would plug the first equation, x cubed plus 1. Okay? And they want it to compare to the parent of x cubed. Okay, well, if I plug this into my equation, they want us to compare it to this. Okay? So it's going to make something like that in your calculator. Okay, bless you. And so if I'm doing this one, it is slightly different in the sense that it has raised one level. Because what is my y-intercept on that right there? On just the parent function, what's my y-intercept? Origin, okay? What's my y-intercept right here in this one? 1, okay? So if it goes from 0 to 1, it's risen by how many points? 1. Okay. Number 5. All right. Barry is planning to raise some money for his senior dues. He will sell sports drinks. Okay? He is considering that letter A, and he's going to be selling them for $1.65. Now, if he sold 10, how much would he make? Come on, help me out here. If he sold 10, how much would he make?
$16.
$16 and 50 cents, okay? So he's making $16.50. All right? So if I want to find out how much his total is, I can just look at the total amount or the total amount of drinks he sells and say, aha, that's it. Now, how much is he selling the granola bars for? How much is he selling those for? 85 cents, okay? So those are at 85 cents, and they want us to look at those as B. Now, quick math. If he sells 10 of these, how much has he made? $16.50. Okay? If he sells 10 of these, okay, he has made $8.50. Okay? All right? So, how would I know what his total is? Add. So what would it look like up here in the equation? What would I do with these two? Add them. Okay? And that is letter B. Okay. Number 6. Okay? This is one on number 6. Okay? Just, you can put this in your calculator, okay, and see which one best fits. But you want to check it, because when you put this in your calculator, all 4 options are negative. So we can't remove any of the options based on that. All of them have a y-intercept of 3. Or in this case, since it's an exponential function, what would we call 3 in this case? We use that word that you just started to see. All right, what would we call the 3 at this? Begins with an A.
I can't remember.
Asymptote.
Yeah, very good. Close enough. Asymptote. Okay? Okay, asymptote. So that it's getting as close as it can to 3, but never ever touches. But there are a couple of points that I can look at. I can look at where x is 1, what does y equal? Where x is 1, what does y equal? Help me out. Look at your graph. Okay? Where x is 1, what does y equal? 2. Okay? So, y is 2. Now, where x is 2, what does y equal?
0.
0. So, where could I go after I've plugged in each of these? Okay, I'll plug it into y1. Okay, plug A into y1. Where can I go to find the answer? The table. Okay, I can hit second, y equals, aha, there's my table. I should be looking for those 2 values. Okay, because all of these are very, very similar. Okay, and so you've got to be able to look at it and go, what do these equal? Or you can just take your x values, if you would prefer, and again, plug and chug all the way down. It's your choice. Which do y'all prefer? Graphing, or do you prefer the plug and chug? What? Plug and chug, okay. Then that's what they're asking you to do. Okay? Then take the x value, see what your y values are. All right. Number 7. Okay, this particular person runs, okay, 2 miles the first day. She wants to run 1/4 of a mile farther each day. Okay, what type of graph would this look like? Are her miles growing very, very quickly?
No.
No, okay, they're not jumping from 2 to 4 to 8 to 16, okay? Are her miles going down, then reach a certain point, then going back up?
No.
No, then it's not absolute value. Is she increasing, reaching an apex, and then decreasing?
No.
No. So what's the only way it can be? It's linear, okay? She's growing at a constant rate. That's what linear is. All right, number 8. What is our time so far?
13, 15.
Okay, let's go ahead and stop right here.